My name is Carlotta Berry, and I'm a professor of electrical and computer engineering at Rose-Hulman Institute of Technology. My area of research is in human-robot interaction, engineering education, as well as robotics education. I have been a professor since 2003, and Rose-Hulman is my second university. And I also just recently, during the pandemic, while I was on sabbatical, have become somewhat of a STEM or science educator on social media. And that's where most people seem to find me. And I go by the hashtag #NowhereSteminist.
Thank you so much. And also, so what led you to pursue electrical and computer engineering?
So when I was younger, my mom was a school teacher. My grandmother was a school teacher. I wanted to be a school teacher. Teaching has always been my ministry. I actually used to hold school for my dollies. I'd set them up, assign them homework, then I would grade it and all of that. When I was in elementary, I was very good at math and science. And so someone said, you should really consider engineering. I had no clue what an engineer was, no cell phones, no internet. I had to walk to the library and actually look it up in a book. It looked relatively interesting. You know, I still was kind of like, is that a train conductor? It was not. But because of that, because my heart had always was into being either a trig, algebra, or calculus math high school teacher, I have 2 bachelor's degrees so that just in case that engineering thing didn't work out, I still had something to fall back on. So I have a bachelor's degree in mathematics from Spelman College, and I have an electrical engineering degree from Georgia Tech, both in Atlanta.
Perfect. That sounds like a very long, that's a lot of education that you have there.
Yeah, it is a lot.
So you obviously took a very long or more educational pathway. What pathway, if someone wanted to go into engineering, would take?
I get asked that question a lot, interestingly enough. So I have a website, nowherestemminist.com, and I've started creating a blog because some of the most common questions I get are how to get kids into engineering, how to get kids into robotics and STEM, how to keep college students in engineering and robotics and STEM, because college engineering is kind of hard. So what I like to tell people is no matter what level you are along that journey, the most important thing is to be curious, be creative, and want to learn and know more, right? So if you're younger, build things. Legos are still good. You know, Tinker Toys are still good. Little robotics kits, snap circuits are great. Gears, my daughter had gears. Anything where you take your mind and put your hands on something and make it come together. Also coding. Coding is free these days. You can go to code.org, you can go to VexVR and do scratch coding, Python, Java. Start wherever you want, whether it's graphical or text-based, object-oriented programming, MATLAB, whatever. But doing things where you become a creator, not just a consumer of technology. Video games are great. Right? You know, if you're doing things like Minecraft and building a whole world, you are being creative, you are using your mind, but how about you design your own video game, right? So that's taking it to that next level. And that's the most important part.
Yeah, definitely. I actually have been on your blog and I read a bunch of your blogs. I mean, I definitely love the more information for college, because since I'm going to college soon, it's very important to know. But since you already mentioned a lot of the ways for young people to get into coding, is there more ways to make it more accessible to young people, especially to minorities who don't have access to such opportunities?
So I think the lowest threshold is, even if you can't get your hands on anything, if you can get to an internet and the computer. Let's say you don't have a computer and internet at home. Library, right? Libraries are still good. They have free computers, they have free internet. You can get in there and get on Tinkercad. One of the things I suggest for some of my students is we do a lot of Arduino coding and building of things. Let's say you don't have access to the Arduino board. Tinkercad is free and it's online, and it is a great way to start building and writing code and seeing what you can do with electronics. YouTube, I have a YouTube channel too. YouTube is a great way to learn, not just from me, but websites like Instructables, Hackster.io. So there's a lot you can do even if the price point is low, right? If you can just get to your local library, or if you have a computer and no internet. I used to tell my students, Panera Bread has free internet. McDonald's has free internet, right? Cell phone. Who doesn't have a cell phone in this day and age? Open up that baby and go to YouTube or go to a website or go to the internet. There are lots of options. Whatever you're going to tell me you can't have, we going to figure out a way to get you there, because that's what engineers do. We problem solve.
Perfect. Thank you. That's a very great response.
Right.
But what sorry, what motivates you to help young people pursue engineering or STEM in general?
Well, there is one of my blog posts that says, you can be what you can't see. A lot of times people say diversity in STEM, more professors, more engineers, because it's hard to be what you can't see. I agree, it's hard to be what you can't see, but it's not impossible. I am a witness that I saw what I didn't see. I didn't see any Black women professors in engineering. I didn't even see any Black women engineers until later in my life. But now we have organizations like the National Society of Black Engineers and Black in Engineering and Black in Robotics, which are on social media. However, it's just really important that we make it better for those who come behind us. I live by two mottos. One of them is, my STEM is for the streets. The other one is, to whom much is given, much is required. So I need to make it better for the generations that come behind me, like my daughter. My daughter wants to be an artist, but she's been doing STEM since she was a baby. She's 13, loves video games, by the way. So if she ever changes her mind, I've now shown her the path and I've shown her the way. That's why I do what I do. So my STEM being for the streets means taking it out of the classroom. I'm still there for my college students. They have complete access to me, but I need to show some people who may not make it to my university that you can also do what I can do. You can be what I am. And it's so important.
Thank you so much. It's definitely great to show inclusivity in STEM, especially
Yeah,
since when you grow up learning that it's mostly a male-dominated field, and
it is.
so you're kind of scared to go into the field, especially me. But what would you say your most memorable project been as electrical engineer?
So obviously I am biased about robotics. So one that I remembered, there are a couple. One of them was in undergrad, my first robotics class. We had to write a program to make the robot do something. And seeing that code work on the robot is amazing. When you think that something you designed actually made something happen. My challenge with it, which is why robotics is also my ministry, is because when I was in undergrad, the robots were so expensive that they only let the graduate students and the professors touch them. That's no fun, right? So we could write the code, we could stand behind the plexiglass, we could watch it run, but we never got any hands-on experience. So that's another thing about my STEM being for the streets. I share things that are relatively low cost and videos so that when I teach robotics to my students, they can get their hands dirty. And engineering has to know how to break things and put them back together. They have to be able to touch things. They got to do it up to their elbows. I do that for women, for people of color. Everyone's got to do that. And you can start that as a young person, right? Take a pen apart, figure out how to put the pen back together. It doesn't take a lot, but I think that was one of the most exciting ones for me in undergrad. Probably elementary school was one of my first science fair projects when I made a simple electric circuit. It was just the battery, wires, and a light bulb. But the coolness of that is that now when I'm teaching my entry level electrical engineering students, first project is still to get a light turned on, right? So those very basic things that you're learning at 11 and 12-year-olds, at 11 and 12 years old, they take you a long way. It's still significant. I think as a grad student, same thing. The first time I wrote some code to simulate some theory I learned in class, and it actually worked, mind blown. A lot of times college students say those who don't do teach. They don't think professors have any real world experience. So when I can show them that that book knowledge that they're learning is some real stuff that they can make happen, that's amazing.
Definitely, it's kind of out of the box when you think of what you're reading is actually an actual thing, because you usually
Absolutely.
just imagine it in your head.
Mhm.
But during your career and your education, what would have been, have you ever had any obstacles during your STEM career?
Yes, too many to name. I won't go over all of them because we're trying to keep it positive because I want you to join me over here, right? I think one of the biggest challenges is when you are a trailblazer or a pioneer or a unicorn and you don't see anyone that looks like you don't always have the mentoring and guidance to know exactly what to do. I had a few scholarships, but not enough to cover my entire education. So a lot of times my game plan may not have been the best. So I sometimes had to work 2 and 3 jobs in order to pay for school. I was a hostess at a restaurant. I was tutoring people in math. I was working at Ticketmaster answering phones. I worked at a credit cards company. I worked in the dining hall of the university. But the challenge becomes what suffered in all of that. I did that so that I could stay in school, but doing all of that made my grades suffer. So, because of that, my first obstacle was I failed 2 classes in undergrad. And I'm very honest about that. And I'm very transparent about that with my students because I don't want people to think you have to be a super genius, a super smart, and have a perfect journey to become a college professor in engineering. You just have to be dedicated, diligent, and hardworking. And even though I failed those classes, I took them over. I learned what I needed to learn. It built me up to know that I understood. And it's how you get back up after a failure that's so important. Work was the same thing. I started working as an engineer at Ford Motor Company in a manufacturing plant, a controls engineer at 23 years old. I was significantly younger than a lot of my coworkers, including the electricians and the millwrights and the engineers. I was one of 2 Black women, I believe. And so I got a lot of misogyny, a lot of ageism because I was young, a lot of racism. And at what point do I decide this is important to me? This is my ministry. This is what I'm meant to do. Am I going to stay despite all of that? And I had to make some choices. And some hard choices were to leave that job and go to a different one, and to go to grad school and start to work on the ultimate purpose for my life, which was to become a professor. So you do face these obstacles along the way. And so you're never going to have a perfect journey, but it's your attitude. How do you respond to that? And what do you do when you fall down?
Thank you. That was that last quote was really memorable. Um, for a lot of people, they face a lot of obstacles, like in education. How does someone know that electrical and computer engineer is for them?
So, what I tell my students is a lot of times you select a major before you really know what it is, right? But now we have the World Wide Web at our fingertips. So, I tell college students, you've got to do your research. You don't have to be like me where you had to walk to the library and find a book. All you got to do is use that little Google machine, right? So, you pick engineering by what interests you. Electrical engineering, for example, has a lot of sub-disciplines. I do controls, I do robotics. There's also power engineers. There's electronics engineers. There's semiconductors. There's another discipline very closely related that's computer engineering, and that's people who may look at information security. Mechanical engineers focus more on motors and gears, but robotics engineers are also mechanical engineers. Another closely related field to robotics is computer science. That's looking at the software aspects. So, in particular, when it comes to robotics, I'll ask students, do you want to write code? Do you want to build like mechanical engineers? Or are you more interested in the controls and the sensors and how to make all that architecture work together? That's like a controls engineer like me. So you decide on the type of engineering you like by discovering and knowing yourself in high school. What do you like to do? Do you like computers more? Do you like working with your hands more? Look at all the different types and also look at what are they going to do when they graduate? That was another thing that I had made a mistake with. I didn't research very well what type of job to take on. Engineering is so broad that I could have gone into a different branch of engineering that was not quite so challenging, like the plant where I went to work. There were other places I could have gone that were a little bit more welcoming to a Black female 23-year-old, right? So doing your homework, your research is very important.
Perfect, thank you. It's definitely important for a lot of young people because not we don't really know all of the majors and all of the little subfields. So
Right.
it's definitely important to know more about it. You also you currently I also looked up that you are working on organizations called Black in Engineering and Black in Robotics. Can you tell us
Absolutely.
a little bit more about it and how to be a part of or help?
Absolutely. So during the summer of 2020, everyone was home. All eyes were on TV and social media. And there were several things that happened. It was a perfect storm of a lot of chaos. Ahmaud Arbery was killed while jogging in Georgia. George Floyd was killed in Minneapolis, Minnesota. And then there was the bird watcher Christian Cooper, who was racially profiled in Central Park in New York. Those were all in the last couple of weeks of May and the first couple of weeks in June. Then around that second week in June, the hashtag Black in the Ivory started trending on Twitter. And through all of those, we started hearing more experiences about Black academics in STEM and the arts and humanities. And birth out of that was all these organizations to show support for each other and to amplify our work and to show that we are out there. We're not all together. There's not this, there's strength in numbers, there's power in numbers, but we're all over the world. So by starting these organizations, it was a way for us to come together, amplify our message, advocate for racial equity. And because I am intersectional and multidisciplinary, my area actually rides the line of several. So I am co-founder of Black in Engineering with Doctors Tahira Reed and Doctors Monica Cox. And I'm also a co-founder and part of the organizing committee for Black in Robotics with several different graduate students and academics and people in government and industry, including Doctors Monroe Kennedy and Ayanna Howard. And I also, because robotics rides the line, I help with Black in computing sometimes. So it was just a way for us not to feel so isolated. We are trailblazers, but for us to know that the experiences we have, we're not alone, right? And when we can come together and build a community and a support network, we can seed the ground and the pathway for young people such as yourself who are coming behind us. And the way that you join these organizations, you tweet us, you DM us, and you say, I want to join the Slack channel. I want to come to some of the meetings. Can you email us? Or you just go on Twitter or Instagram or TikTok, Facebook, wherever we are, and you start sharing your experiences in the journey, and we amplify you as well.
Perfect, thank you. That's actually very true to our organization as well. We started during the COVID pandemic to help because during the COVID, you don't really have a lot of opportunities since it's all
Mhm.
online. So offering more opportunities
Yeah.
online has definitely been a very challenging but a rewarding thing to do. What would you say your future plans are in terms of making things more inclusive and your career in general?
So a big one is Black in Robotics held several workshops over the last year from November. We actually just ended a couple of weeks ago. We have sponsors who give us funding in order to do more outreach and make it more accessible for young people as well as old people. I am in charge of undergraduate liaison as well as outreach for Black in Robotics. We're going to continue the work. Actually, in about a month, we're going to do some workshops for some young people in Lagos, Nigeria. And it is so important for us to get our work out to those areas that don't have access to the technology we do. So we had people from all over the world attend our workshops before, but we now want to show them how they can do it. This is one of the questions you asked me earlier. This workshop we have, those young people don't have access to technology. They do have a laptop and the internet. So I'm going to design a Tinkercad workshop for them that their mentors can then continue with them beyond myself. So those are some of the things we're going to be doing with Black in Robotics, as well as Black in Engineering doing outreach. But because I am a professor and my sabbatical is now over, I also have to return to my university. So as part of my work with my university, I will continue to do research in human-robot interaction, but I'm going to then work with those students to design programs that we can do for outreach as well. Because the most important part is to make this accessible. Because before this pandemic, what were the chances of you ever being able to find a Black woman engineering professor in robotics that you could easily talk to? By amplifying our work more on social media, it makes it easier for you to find us and to connect with us so that we can have these important conversations like we're having now.
Yes, definitely. The work that you're doing sounds very motivational. Do you have a quote or a saying that you revert back to or say sometimes to help you power through something?
So I've given you the ones that are my mottos for how I live my life, but the one that I stick with when it's hard is actually a Bible scripture, and it's trust in the Lord with all thine heart, lean not to thine own understanding, in all thy ways acknowledge him, and he will direct thy paths. So when you're going through something and it's not going well, it's to sit back and center yourself. And if you know you are being your authentic self and doing what it is that you have purpose in your heart to do, he will direct your path. I've always known that my spiritual gift was teaching, whether I'm teaching high school math, whether I'm teaching engineering, whether I'm teaching online through social media. I'm walking out my path for life. So I'm doing authentically what I'm supposed to be doing.
Thank you. That's a very great quote. Do you have any advice for the future generations that are planning to go into engineering? Just something small or long, just any advice.
My most important advice for you, I think I've already given it, and it is to keep connecting with people and ask lots and lots of questions. Do all the research that you can so that you're more than aware of what you're going into. And if it excites you, stick with it. Don't worry about obstacles along your pathway. Don't worry about what the naysayers say. Girls don't do good in math. Girls don't do STEM. Engineering is for white guys. You close your ears and you keep your eyes on the prize and you keep moving forward.